My favorite sun fact really is that the sun is a dynamic magnet. I think that is so cool. And the first time I encountered that, it was kind of mind-blowing, to be honest, because I hadn't thought about it, right? You just think about the sun as this like bright, fiery ball. Space weather starts with the sun. The sun is always emitting material, solar wind, plasmas, and it sets it off throughout the solar system, and that's sort of the background for space weather. But we get things like storms. Coronal mass ejections are big solar eruptions, and they have lots of material and lots of electromagnetic field, and those things propagate throughout the solar system.
We hear about magnetic fields with the sun.
Yes.
What are solar magnetic fields?
Okay, what are solar magnetic fields? Well, we're going to get into the basics of plasma physics with this. So plasmas are collections of charged particles. So they're electrically charged particles. And when they move, they create magnetic fields. And the sun is made up of different types of plasma. It's real complicated on the sun because we have small-scale magnetic fields and then we have very, very large magnetic fields. So I think everybody or most people are familiar with the idea of a magnetic field from a bar magnet. In quiet times, at solar minimum, the sun is essentially a bar magnet. The magnetic field is kind of like this. But because it's not a solid body, it's not made of a solid material, it's made of this plasma, right? It's twisting and moving, and so the magnetic fields get all sorts of twisted up, which is what gives us things like sunspots and coronal mass ejections.
Why is it important to understand space?
It's really important to understand it a lot today, like in today's society, because we have so much that depends on electricity. Our electrical grids, our satellites, our communication satellites, all of these things can be impacted by these big solar eruptions because they are electromagnetic storms, essentially. So when you get buffeted by something like a coronal mass ejection, it can cause charging on your satellites, it can disrupt them, it can cause large electrical currents to run through our power grids and potentially be destructive there as well. Solar eclipse is an amazing time to study the sun because we are positioned sort of perfectly, and the moon is positioned perfectly to block out the very bright disk of the sun so that you can see the corona, which is the solar atmosphere. It's very diffuse, and the moon is positioned perfectly just to block out the surface of the disk and nothing else. And so there's nothing else that's made by humans that allows us to see very, very low in the corona.
Why is it difficult to see the corona during normal conditions?
The surface of the sun is so bright, right? When you look up in the sky, you just see this bright ball. And so it's so bright that you can't see what's happening in the atmosphere, in the corona. So under normal conditions, you won't really be able to see the corona. You have to have something blocking out the surface. A sunspot is really cool because they are actually visible. If you have appropriate viewing glasses, you can actually see a sunspot. So they're dark spots on the surface of the sun that are regions of high magnetic field, so very, very concentrated magnetic field that gets super, super twisted up, and they can grow, they can change their shape, they can shrink. A solar flare is another type of solar eruptive phenomenon. So a solar flare is a very bright flash of light that has very, very fast particles. It energizes sort of small amounts of particles to be almost the speed of light. So it's different from a coronal mass ejection, which is a very large eruption of billions of tons of material. Solar flare is most noticeable because it does a very flashy thing. Solar flares are also disruptive. Yeah, they can be. The particles, when they hit Earth's upper atmosphere, can cause the atmosphere to sort of to grow a bit. And because the particles are so energetic, when those things hit satellites, they can be disruptive to satellites, cause charging on the surface. So understanding the solar environment, the atmosphere, the background, what's happening there, and then when you have storms erupt is really important for monitoring these systems because these systems can be so disrupted. So it's a lot of stuff that we don't necessarily see on a day-to-day basis, but is important to understand in the long run.
What is the most exciting thing for you about space weather?
The most exciting thing for me about space weather is the day-to-day changes. It's really cool to be able to look at the sun and track a sunspot that you see growing or changing in complexity and try to guess if it's going to erupt. And this is something anybody can do. You don't have to be a scientist to be able to do this. I really like monitoring features like filaments, which are these long magnetic structures that can grow on the sun and they can erupt too. So it's fun. It's fun because it's dynamic. On a day-to-day basis, it's fun because it's always changing.